Hello and welcome to my Pre-Algebra review series. This video covers Chapter 7, Section 8, Simple and Compound Interest. By the end of this video, you should have a better understanding of interest formulas and their use. You'll learn about simple interest and compound interest and the differences in their applications. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It'll more than likely help them, and certainly it will help this channel be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Let's do some math. Before we get started, there are a few definitions I'd like to introduce you to. First, being principal. The money that you deposit into the bank is called principal. Okay? Interest. The bank takes your money and invests it. In return, they pay you a percentage of that money called interest. Interest rate. The money they pay you is based on a percentage, and that percentage is the interest rate. Simple interest. Simple interest is the interest paid only on the principal. Compound interest. When the bank pays you interest on the principal and the interest previously earned, that is called compound interest. The balance. The principal plus the interest previously earned that remains in the account is called the balance. Okay, let's talk about simple interest. When you first deposit money in a savings account, your deposit is called principal. The bank takes that principal and invests it. In return, the bank pays you interest based on an agreed rate of interest. Simple interest is interest paid only on the principal. The interest earned is then paid to you at the payment date. There is a formula that is used to calculate simple interest. Let's take a look at it. Simple interest formula. The formula is I equals PRT, where I is the interest, P is the principal that you deposit in the bank, R is the rate of interest that you're going to earn per year, and T is the time in years that you're going to leave the money there to collect this interest at a certain rate. So let's take a look at a real world problem. Suppose you deposit $400 in a savings account. Right here, your $400 in your savings account right there, $400. The interest rate that the bank is paying is 5% per year. And remember, 5% is 0.05. 5%. A. Find the simple interest earned in 6 years. Find the total principal plus interest. Okay, we're going to write the formula. I equals PRT. I equals 400 times 0.05 times 6. The 400 is your deposit. The 0.05 is the interest rate that they're going to pay you on it. And the 6 is the number right here. The 6 is the number of years you're going to keep it invested. So you have the 400 and the interest rate, and we're going to end up having a calculation completed here. What is that calculation? Well, I is going to be equal to 120 because all these are going to multiply. 400 times 6 times 0.5. So the total is 400 plus 120 is equal to 520. The account will earn 120 in 6 years total. P plus I is 520. B. Find the interest earned in 3 months. Find the total of principal plus interest. So again, we use the I equals PRT. I is equal to 400 times 0.05 times 1/4. So it's going to be paid every 3 months. As they said, earned in 3 months. They're going to pay you in 1/4, apparently, in 1/4. Okay? The same numbers. Now we end up with the I equal 5. We've multiplied 400 times 0.05 times 1/4. And if you look at it, it's a fourth of 400 is 100, and 0.05 of 100 is $5. So the total, 400 plus $5 equals 405. The account will earn $5 in those 3 months. The total, P plus I, is 405. So you're going to take the 400 that you started with, and you're going to add the $5 to it. So that's the total principal at the end of the period. $405. You see it, it's right here. Total principal at the end of the quarter or 3 month period. And this one up here on top, the total principal at the end of the period of 6 years was $520. We started with 400 and they ended up with 520. That's because they earned in those 6 years $120. So in example 1, we're going to check our understanding. We're going to go over a few more problems. Let's find the simple interest. The principal is $250, right here, $250. The interest rate is 4%, or what is that? That's 0.04. Okay? And the time is 3 years. So filling in the numbers here, I, if we're trying to find the interest, is equal to P, which is 250, times R, which is 0.04, times T, which is 3. When we calculate all this out, 250 times 0.04 times 3, we end up with I equals $30. So that account earned $30 in 3 years at that interest rate on $250. Principal, on B here, principal $250, interest rate 3.5%, and the time is 6 months. Same formula. I is PRT. So we're going to go here. We'll say I is equal to 250, same as the previous problem. This time the interest rate is 3.5%, not 4%. So it's 0.35. It's a little different. And the time is 6 months. So based on a year, 6 months is 6 over 12. It's 1/2. For 1/2 a year, they're going to pay this. That comes out to, when you multiply this all up together, you get $4.38. So we talked about simple interest in the last set of slides, and now we're going to talk about compound interest. So when a bank pays interest on the principal and on the interest an account has earned, the bank is paying compound interest. The principal plus the interest is the balance, which becomes the principal on which the bank figures the next interest payment. So every time they pay interest, it accumulates in the account, and now you have a new balance in the account because you added the principal to your original amount, the amount that they paid the interest on, and they pay the interest on that whole sum, and then that interest gets added back into the account. So it keeps growing. It grows faster with compound interest than with simple interest, because now you're compounding on the interest that's earned. So let's look at a real-world problem. You deposit $400 in an account that earns 5% interest, compounded annually. That's once per year. What is the balance on your account after 4 years? In your last calculation, round the interest to the cents, because it's probably going to be a longer number than just cents because of the multiplication. So we're going to start off in year 1 with $400. Here it is right here, $400. And at the end of that year, we're going to have the $400 and we're going to earn 5% interest on $400. 400 times 0.05, excuse me. And that equals $20. So your $400 earned you $20 after keeping it in the bank for a year. So now what do you have? You have a $420 total, $420. And that 420 is now brought forward to be the balance in your account at the beginning of year 2. Here's $420. And you're going to earn that same 5% interest on your money, except this time you're earning it on $420. So the $420 now earned you $21. It was $20. This time it's $21 because you earned 5% of the extra $20. So now you have 420 plus 21 is equal to $441 at the end of the second year. So that 441 becomes the beginning principal in the account for the next year. So now we're going to add, we have the 441 times 0.05 interest, 441, 405. Now you get $22.05. So when you add that all together, you're going to get $463.05. $463.05 gets brought into the account, or is already in the account, for the beginning of the fourth year. And you have another 5% times, this time, times $463.05. And when that's all said and done, you get 463.05 plus 23.1525. See, the decimal is getting longer because of all this multiplying of fractional numbers. Well, when you round that to cents, that's going to round to $486.20. So there it is. After 4 years, you're going to earn $468.20. Okay, so we have a couple check your understanding example problems. Make a table and find the balance. The interest is compounded annually in this first table. So we're going to start, the principal is $500, the interest rate is 3%, and the time is 2 years. So what do we have? We have $500 deposited on the very first day, and that over that course of that year, that $500 earns 0.303%, which totals $15. 0.03 times 500 is $15. Well, that $15 is now added to the $500, and we end up with $515. Now that $515 gets brought over here to be the input to the second year, the balance at the beginning of the second year. And then we still earn our 3% right here on the $515, though, not $500. Now we're earning it on $515, and that means we've earned $15.45. So that means that this $15 that was added in here earned 45 cents, because 15 and 15.45, that little extra bit earned us a little extra bit in interest. Okay, so that gives us now at the end of 2 years, $515 times plus 15.45 is equal to $530.45. That's the balance at the end of 2 full years. Let's look at B. Principal, $625. Right here, $625. The interest rate is 2%, and the time is 4 years. Okay, we're going to do the first year, $625 from right up here, $625. 625 times 0.02, which is 2%, is $12.50. We add the $12.50 to the 625, and we end up with $637.50. That $637.50 is the input to the second year. It's your balance at the beginning of the year. This time, the 2% on $637.50 earns you $12.75. You add that $12.75 to the principal that you started with, and you have $650.25. As before, the $650.25 becomes the start of the third year. $650.25 times 0.02, right here, 0.02, same, everything stays the same, except this principal is growing every year, and we end up with $13.01 paid in interest. So $650.25 plus $13.01 gives us $663.26, and that $663.26 is the beginning for your fourth year, and $663.26 times 2% is $13.12, 1327, and 663.26 plus 1327, the interest earned this year. So at the end of the year, you're going to have $676.53. So now we're going to deal with compound interest. Previously, those were all simple interest calculations. Now we're going to do compound interest. It's going to be more complicated. In fact, you can see here by looking at the screen that the formula is more complicated. So when you first deposit money into a savings account, your deposit is called, and as we know, the principal. The bank takes the money and invests it. In return, the bank pays you interest. We know that too. And that interest is based upon the interest rate. All common information. Simple interest is interest paid only on the principal. Okay, because every time we took the interest and put it back in the beginning, that was the principal. But compound interest is the formula. We're going to look at this formula, and it's B. Well, it's for the final balance. We're going to call it here balance. At any moment, it's at the end of this equation. The balance is going to be the B, and that's equal to P, the principal, times the quantity, 1 plus R, 1 plus the rate, raised to the n power. And the n power is the number of periods that you're going to calculate this at. It could be once a year or twice a year or 10 times a year, every other year. So that number n is based on how often you want to make this payment. How often will this formula be run to recalculate a new base payment? A new balance. Okay, so we're going to use the formula to solve number 2 above. Okay, and at that time we had the 400. We had a 400. We got the formula here. We used 400 from the previous example and 0.05, and it's 4 years. You recall it was $400, 0.05% interest, and for 4 years. Okay, 4 compoundings. So n's 4, the rate is 0.05, principal is 400. We're going to simplify it. What does that come out to? If you multiply this out, you end up with 486.20. Well, I think that's exactly what we had before, 486.20. But we're using a different formula. Okay? So, which is not bad that we're using one, but this will be more useful, certainly in compounding situations. So when interest is compounded semi-annually, that's twice a year, you must divide the interest by the number of interest periods, which in this case would be 2. If you went twice a year, you'd be getting 2 payments in that year. And what they want you to do is they want you to take they say divide the interest. So if in this case the interest is 5%, they're going to want you to divide it by 2, and it'll be 2.5%. It's going to be 2.5%, but you're going to compound twice, 2 times in the year, not once. Okay? So here's another example. They're going to say 6% annually divided by 2 interest periods is 3% semi-annually. Just what I said. You take the interest rate and divide it by the number of payment periods, and you end up with, in this case, half. If it was 4, you'd end up with a quarter. If it was 12, for 1 every month in a year, you divide the interest into 12 pieces and compound it 12 times throughout the year. And what you'll find is that your principal will grow faster, a little bit faster, because every month you're putting a little bit more interest into the pile. So to find the number of payment periods, multiply the number of years by the number of interest periods per year. And that's, so if it's twice a year for 30 years, you're going to get 60. So that's what they say, the number of payment periods times the number of years by the number. Okay, so that's what we're going to do. To find the number of payment periods, multiply the number of years by the number of interest periods per year. Okay? So let's look at a real world problem. Find the balance on a deposit of $1,000 right here, that earns 6%. Remember, that's 0.05%. 0.06, 6%, compounded semi-annually for 5 years. Semi-annually means twice a year for 5 years. Okay? So the interest rate R, right here, R, for compounding semi-annually is, for this problem, is 6%, 0.06, divided by 2, or 0.03. The number of payment periods, N, is 5 years, as I stated right here, 5 years. So times 2 interest periods, which is every year there's 2 interest periods. So that means there's a total payment of 10 payment periods. Every year they get 2 for 5 years. That's 10. So if you put it through the problem, the formula, we have the final balance is equal to P times the quantity 1 plus the interest rate that we calculated, which in this case is going to be the 3%, raised to the power n, the number of periods that we're going to be compounding. So we start off, B is equal to 1,000. That's our deposit right here, our original deposit. 1 plus 0.03 is just that. 1 is going to be 1.03 will be that total. And we have to do that, this inside the parentheses here. You have to do these inside the parentheses and come up with this number before you can take it to the 10th power. And you'll end up probably using a calculator for this, by the way. And so we're just not going to be solving them right now. We're just going to leave it to fate that the number calculated came out to be in the final balance after 10 compounding periods was $1,343.92. So that's it, $1,343.92. So that $1,000 in 5 years, 2 payments per year, that's 10 payments, ended up earning $343.92 over those 5 years. So let's check our understanding. Find the balance for each account. Deposited $900, annual rate 2%. We got the 900, we got 2%, and 3 years. So 3 years, it's this annual rate. Okay, and it's deposit, say it's compounded annually for A. Okay, annually. So that means that we're not going to be multiplying the number N, the number of years. We're just going to use the straight up 3. So in this case, here's the formula we've been using. B is equal to P times the quantity 1 plus the rate, the new rate that we calculated, to the N, the number of periods that we're going to calculate, run this through. So we start off with 900. That's up in the equation up here. 900, right here, 900. Times 1.02. 1.02. And it's 1.02 because we're not semi-annual or quarterly or anything. It's once per year. So, and that means 1.02 times or raised to the 3rd power. So this 9, if you're going to do the problem, the 9, you can't multiply this. If you remember PEMDAS, PEMDAS says you have to do what's inside the parentheses first, right? To do what's in here, do what's inside the parentheses, because that's, and then you have to raise that to the power, in this case, the power of 3. And then after you do that, then you could multiply by the 900. And when you do that, B is going to be $955.09. So it earned $55.09 in those 3 years. Let's look at B. B says compound semi-annually. And what is semi-annual? That's twice a year. Okay? Again, B is equal to P times the quantity 1 plus R to the nth power. So what do we have? We have 900 is the B, is the principal. 900, that's the deposit. 1 plus 0.01 in this case, because why? We took the R, which was 2%, and it was semi-annual. That means 2 periods. So we're going to take the 0.2 and divide it by 2 and get 0.1. Okay, that's how we get the 0.1. Here's the 0.1. Added together is 1.01. 6 periods. How do we get 6 compoundings? Because we went 3 years and it's 3 years times 2 interest periods per year gives us 6 total periods. And when we do this mathematics, B is going to be 955.37. Look at that. Since the compounding is going to show you a little example of what happened. Since the compounding here was 2% three times, 2% 3 times, you get 955.09. But because this was paid 6 times every half year at a lower interest rate, you earn a little bit more money. And how much was that a little bit? 37 minus 9. So, that's a little bit of extra cash. Okay? So let's look at a few exercises. We're on our own here. No formula, nothing. We'll have to dig this formula out of our heads, I guess. So we're going to start off. We have $3,000, 14% interest. That's good interest. I'd like to earn that today. Compounded annually for 4 years. So that's 1 interest payment per year. 1, remember that. 4 years. And what was the formula? I think it was B is equal to P times the quantity 1 plus R to the N. Okay, so B, again, B is equal to P, and the P is $3,000 times 1 plus what? Oh, 14%. And 14% is how much? 14% is 0.14. Okay, 0.14. Raise how many times? The nth power here is 4, because there's no extra compoundings during the year. So if we run this magic out here on this, we're going to have B is equal to 3,000 times 1.14 to the 4th power. So if we put this through our calculator, we're going to find out that the answer is B is equal to 5,066 on a 066. 5,066 88.88. So there it is. I'll write it again. 5,066.88. B is equal to that amount right there. Okay, let's do the next one. 500 at simple interest. 3% for 4 years. Do we remember what the simple interest formula was? It was I is equal to PRT. So 500, so I is equal to P is principal, 500. R is 3% times 0.03 times 4 years. And 500, so we're at 2,000 times, so let's see, I equals 2,000 times 0.03, and if you look at 1% is 20, so 3 is equal to 60, so I is equal to $60. Okay? Our next problem, 3, is they want us to do compound semi-annually. So we've done the semi-annuals before. Writing the formula, B is equal to P times 1 plus R to the N. And what do we have here? We have B equal to P. The P is $54,500. It's a good investment. Times 1 plus 3% semi-annually. So that means 1.5%. We have to take the 3% and divide by 1.5 by 2, and we're going to get 0.015. And raised to the how many? 9 years. But is it 9 years? It's 9 times the payment periods, which is 2. So it's 9 times 2 is equal to 18. So it's to the 18th power. And we're going to get this solved here. Okay, if we run that through the calculator, we're going to have B is equal to 71,250, 71,250.06 cents. I would say dollars over here. So what do we have to do? We had to add these two together. So we had it 1.015. We raised that number to the 18th power, 18 times. And then we multiplied by the 54,500. And for our last problem here, it's a simple interest. Well, these are a little easier usually. So simple interest is I is equal to PRT. So I, the interest, could be paid, is equal to $35 times 2.5% times 0.025. That's 2.5% for how many years? 1 year. So 35 times 0.02 or 2.5%. So I think that's going to be what, 35. That's going to be 35 cents. 2.5 times, so 70, and well, let's do it on the calculator. And this equals, when we get it calculated, it's 87.5 cents. So the interest on $35 at 2%, 2.5% for 1 year is equal to $0.875 or 87.5 cents. I'll write it here. I is equal to 87.5 cents.